everyone. Thank you for being here. I'm excited to chat with you. My name is AJ Steers. I am at Airbyte. We're going to talk about GenAI data pipelines. You can turn down a tiny bit. And walking through the phases from exploration to prototype and production. So glad you could make it. Here's what to expect. We're going to talk about the first 8 hours, the exploration, and obviously it's not everyone going to take 8 hours, but let's say maybe 8 hours, 8 days, whatever, but on an order of magnitude, the first phases of your project, first 8 weeks, and then 8 months, assuming your project lasts in production for 8 months. What does that look like? We'll talk about ELTP as a new model for designing data pipelines that can be adapted for AI use cases, and while not throwing out the best practices of data engineering that we've learned along the way. So we're going to be emphasizing internal use cases today. We're not going to be as much focusing on building external products, but all the design discussion here and all of the principles will apply as well to products, except we're not going to try to handle all of the other things you have to deal with when building an external-facing product. All right, so I'm going to talk a little bit about Airbyte so you know where we're coming from and what the tool is. Quick raise of hands if you've heard of Airbyte or used Airbyte before. All right, great. Airbyte is built on open source, and so we have great coverage of long tail of connectors, and we have a whole slew of certified connectors that Airbyte directly contributes to, as well as community connectors and partner-provided connectors. And we've also heavily invested recently in unstructured document sources, vector store destinations, and the ability to run anywhere, which I'll talk about in just a second. We have, as I mentioned, a very large connector catalog, 285 total sources. I'll talk about what no-code sources are, these YAML sources, and Python-based sources. How many people use Python on a regular basis here? Oh my God, yeah, a lot. Great. So it's relevant to know which connectors are built in Python. We have connectors built in Python, Java, and a few in other languages like Go. There's no real language restriction for the ecosystem. If you want to build a connector in any language, you can. But most of them are in Python, and a large number of database sources are in Java. We also have about 10 vector store destinations and about 40 destinations in total. And just a huge number of members in our community. We're humbled constantly by people contributing to these connectors and the ecosystem as a whole. So a little more about Airbyte. This is going to become relevant when we talk about productionalization. But there are basically 3 channels or paths you can go with Airbyte platform. Open source, deploy anywhere on Kubernetes. It's yours to support, and you don't have to pay a thing. Airbyte Enterprise, that's a self-managed, but with the support of the Airbyte team, and with enterprise features and capabilities built in. And then Airbyte Cloud, which is if you just don't want to think about infrastructure at all. What we are bringing now is PyAirbyte. PyAirbyte is a new addition. It runs entirely in Python. We'll be demoing it today. And it brings not the entire library. Well, I guess, let me say, it does bring the entire library if you've got the runtimes to support it to run in Python. And I'll talk about the distinction on those in a second. So why do we build PyAirbyte? We built PyAirbyte to break down the barriers and silos between teams. There was a data engineering team using one set of tools, data warehousing team using another set of tools, machine learning team using Python and Colab and Jupyter notebooks, and there was no way to share work amongst teams. We built PyAirbyte as well as for the GenAI use cases, to bring together these disparate teams so they can work on a common foundation and a common data stack. A little bit about myself. I started as a young, I think I started as a data entry analyst and then started automating everything at Bank of the West for BNP Paribas. I moved to Seattle to work for Amazon EC2. I started a BI team there that now is handling AWS BI. I then moved to Amazon Prime Video. I was one of the first internal teams to deploy Redshift in its private beta. And we built basically the system that processes all the streams that you watch on Prime Video. It's a big system. I worked for Slalom, and through Slalom, I had an awesome experience at Starbucks, helping build the Starbucks 2.0 rewards program. And this is not everything I've done, but prior to joining Airbyte, I was at Meltano, also working on open source data. And yeah, so this is a little bit about my journey. I mention this because I'm not coming from a theoretical standpoint. I've been a builder of systems for a very long time, and I've seen how they fail. I've seen where the investments pay off, and where prototypes never reach production, and that's always sad to see. So hopefully we'll be able to prevent some of that. All right, so let's get into some data pipeline design principles before we get into the stages. I like to start with this one. Everything should be as simple as possible, but no simpler. And we're going to talk about where complexity can shoot you in the foot. But just starting off with, we want simple designs that are composable. And by taking simple designs that are composable, we can build very complex and powerful things. Each step in the pipeline ideally would be simple and obvious. And then also when it breaks, it has a simple and obvious and easy remedy. And another way to think about this is if your pipeline fails, which part of it do you have to retry? Or is it just a code fix and you let it run again? Or do you now have disastrous things to go fix? All right, stability is a myth. It's the second principle here. Your business requirements are going to change. Your data is going to change. Your source system is going to change. Your packages are going to change. You have to plan ahead that things will change both while you're building your solution and then afterwards, especially for data pipelines. You might just deploy it to production. 2 months later, the source API changes. What are you going to do? And then last, this is kind of back to the simplicity thing. If you want your pipelines to go fast, do less. So I see people building pipelines that are sorting data sets in memory, and that will work fine as long as your data set is less than 1,000 or 1 million records. As soon as your data set grows, that part of your pipeline is going to crash because you cannot count on that to be memory processing. So that is why Airbyte uses a thin EL pairing of extract and load data sets, and this is a design pattern you should try to replicate wherever you can. That data replication job should have as little as possible that can fail. And it shouldn't have, I know a lot of ETL tools are popular because you can just do everything in the wizard or everything in the canvas. But the problem is that won't scale in the long run. So simpler design patterns are best. All of these things are the T. So we will do them, but we'll do them in the right place at the right time when we have horsepower behind them. So let's say, for example, doing aggregations in flight is just asking for trouble. But after you've landed in Snowflake or Databricks, your storage of choice, you can aggregate more efficiently there. And if that fails, you just retry that part. You haven't lost the data extraction process itself. All right, so then with those principles, we end up with a model of ELTP. To understand ELTP, you start with the traditional extract, transform, load. This is a very unfortunate acronym, but ETL is a bad word in my book. Don't ever use it unless you mean this more loose legacy approach. What we've generally, as an industry, adopted is ELT. The E and the L, their job is to replicate data. After you've replicated the data, you can transform it. There's some exceptions to that, which we can dive into if you want, but there's basic thin mappings that we sometimes have to do. But as a rule, we want to do an ELT. And then as soon as you start thinking about vector stores or reverse ETL, or even just people who are going to query your data or access your data in a different place than you are processing it, you have to think about publish. You have to think about your publish step or your steps. So the clearest example here is you might push to Pinecone. You might take your raw data, extract and load it, land it in Databricks, transform it using your tool of choice, and then publishing it to Pinecone might be your final step. In some cases, you actually might have data sets in Databricks that are themselves internal use. So your publish step might also be pushing a data set to the end users. It's still a Databricks data set, but it's in the public domain and not the internal domain. So always think about what your publish step is and think about ELTP. One last thing before we leave this slide. I mentioned thin pairings of extract and load. Extract and load right at the beginning. HubSpot is just an example, of course. You extract wherever you want. And then publish, likewise, is just a thin EL pairing as well. We call it publish to distinguish it from the original extract and load of raw data, but itself is an extract and load. So you think of it 2 EL pairs with a transform in the middle. Again, we're trying to keep this simple so it can scale, right? So that when you go to production, you're already ready with a good design pattern. All right, so there we go. No legacy ATL. So we don't want to do these things in flight. If you do them in flight, I warned you. Yeah. All right, so now let's get into the fun stuff. So we're going to explore data, and I'm going to give a quick demo of what your first 8 hours might look like working on a data project. We're going to use PyAirbyte for this. We already talked a little bit about what PyAirbyte is. You can pip install it anywhere, including notebooks. And here's a little bit of what the code looks like. There are different ways to run this, but this is a simple example. You get the source, you give it a name, or you give it its name, and a simple amount of config allows you to pull data. What's great about this is not, yes, we try to make it as elegant as possible, but what's great about this is that it is completely abstracted from the nuances of the source itself. Source GitHub could be an API, it could be a Python library, it could be a REST API, Graph API, and I don't have to change that much to switch between sources. So the best practices are built into the sources, they're built into PyAirbyte and Airbyte itself, and you can focus on just getting the data that you need into your systems. All right, here we go. So let's go to first our basic demo. And can everybody see my screen and read the font fairly well? Bump it up a little bit. So notebooks, yes, everybody can see? Okay. Colab and also Databricks do not come installed with virtual environment support. I know a lot of you raised your hands that you know about Python, so you know about virtual environments. When we are installing Python connectors with PyAirbyte, PyAirbyte will automatically create a new virtual environment for you so that there's no conflicts between connectors and installs as a Python library. So this is just a prerequisite for that to work, and then you install Airbyte as you might expect. There we go. Okay, so after I've installed it, import Airbyte. We like to use AB as an acronym, I mean as a abbreviation, but you can use whatever you want. So here I'll just run a quick list of how many connectors. There's 263 connectors here. If I put the word Python here, oops, I should still get 263. These are all the connectors you can install with pip. And I'll just remove the length so you can see the connectors list. So Smartsheet, Sonar Cloud, Slack, Spotify. I won't be able to read this whole list, but it's a good list. And there's another list you can pull here if you don't have virtual environment support, or if you just want to install the connector without having to do a separate pip install, and that is YAML. So we're investing a huge amount in our no-code builder, which basically walks you through the design steps of building a connector through a friendly GUI, and that saves as a YAML file. That has all the endpoints described, pagination rules, incremental, all of that stuff. And these are all the sources that already are installable with YAML. You can also build your own. So this list is 137. And if you happen to have Docker, not everybody does, and we don't want to bias towards having Docker installed on your runtimes because Docker is messy. But if you do, then there's 289 total connectors you can use. So we're trying to make as many usable to as many people as possible without having the prerequisite of you must have Docker. All right. So now that we've got that, I just want to quickly, Google added some AI since the last time I did this demo. So we're just going to do source GitHub equals ab.getSource. I'm going to say source GitHub. I'm going to say config equals, and I think it's repositories. Let's do Airbyte HQ quick starts. And that's just the configuration. And let's see if we can do this by hand. So we're going to do, I think it's personal access token. And PyAirbyte comes with some secrets support built in, so you can get secret, and I think it's called GitHub personal access token. So let's try that. I might get an error message, and that's okay. Oops. Hold on, what did I got wrong here? Okay. Personal access token. Right. All right. So Colab does this nice thing to make sure that I'm actually intending to do what I intended to do, and I can just say yes to that. The secrets that we support right now are Colab secrets, environment variable secrets, and .env secrets. So if you store your secrets in a .env file, you can use it from there. So my error message here is, it looks like I did not get the correct, I'm going to keep moving because I'm going to run short on time. Sorry about that. I'm going to just quickly do a different demo real quick so you can see it working. There's also an option where you can just print the config that is needed so that you can figure out the config. What has it got here? Maybe we need install if missing equals true. And maybe I did not successfully install virtual environment support. I think I didn't run this cell. All right, so I'm gonna keep moving in the interest of time. Sorry, the demo I'll do another better demo in a sec, but I wanna keep moving through here. So the summary here, though, is that regardless of the source, you can access the data through the same pattern. Let's see if this works. Yeah, this is working. Okay, so I neglected to run the first cell again with adding virtual environment support. Nice to see that live demo principle of anything that can go wrong live will go wrong live. And I'm just gonna, while this is running, say results equals get, I'll say source github.read streams equals issues. And, oh, I changed it to faker, so let's just say products. Okay, so this is showing us that we are reading live data from the source. It prints out how quickly we are reading the data. It prints out that we are done. And once we are done, we can send this to pandas with results, results, product, 2 pandas. So if you are using pandas, how many people here use pandas? Good number of people. Yeah, if I can type, products. So yeah, okay, so here we've extracted the data from the raw system. We got a printout of while it's running, and we can print 2 pandas. Remember I said we shouldn't do certain things in memory? It sort of looks like we're doing it in memory because we haven't defined a destination. But PyAirbyte just automatically uses DuckDB for you if you don't pick a different cache or destination option. So even though it has immediately stored the data and we're able to read the data and analyze the data, we didn't violate that best practice. We just stored it in DuckDB automatically. If I wanted to put it in Snowflake or Databricks or BigQuery, I could have done that as well. And then lastly, I just want to show that there's also a 2SQL table because DuckDB is a database. You can also query it as a SQL table. All right, I will keep moving from here. All right, so that was the basic demo and exploration. So we've now gotten our data. If I had more time, I need to keep moving. If I had more time, I'd show you some more data exploration we can do, but you all know how to use pandas. There's a bunch of great libraries for exploring data in pandas. And we got the data without having to spin up an external service. We were able to pull up as many streams as we want from whichever sources we want, and we have all that data locally already stored in a DuckDB database for our analysis or in pandas as we need. So here's the challenges of the prototype stage. You've got this data, you've got this idea how to do it, and for, let's say, somewhere between 4 and 8 weeks, you are, depending on how complex the project is, you're iterating on the models, you're iterating on transformations, you're iterating on which streams you actually need, which streams you don't, and you have to prove value while you're still continuing to tweak your implementation. There's a common challenge of how much automation do you invest, how early? That's always a challenge because all the time you're spending on automation, you're not spending on iteration, but all your time you spend running things manually, you're not spending on iteration either. We started with PyAirbyte to have everything easy to run and working well right from scratch. I didn't demo it, but next time you run that read operation, it's automatically incremental. So you're not spending a lot of time updating your data sets all the time. You just read it again, and it'll update it automatically incrementally, and dedupe the data with primary keys as they're defined. Also, this is where you'd want to understand requirements. I won't go through all of these details, but it is important to think of basically while you're building the prototype, what does it need to solve? What are the constraints? And here's this scrappy versus perfectionist spectrum. Every hour you spend automating and every hour you spend manual processing is time you're not spending on iteration. Generally, the solution is automate just enough to keep iteration cycles tight. Don't reinvent the wheel. The farther you go off the tracks to build your custom things, the harder that is to maintain. All right, so one more thing here, and we'll show this in a second. In a traditional tabular world, everything is columns, and you might have 10, 15 columns in your data set. And in LLM paradigms, you're going to need those as documents. And it seems pretty simple. Oh, I'll just take all the fields and I'll YAMLify them or something. In practice, that doesn't work great because you end up with a lot of noise, and there's a lot of fields there that you don't actually want. So PyAirbyte does have this interface, and most other document stacks or LLM stacks will have this interface where you pick which are going to be your title fields, which are going to be metadata inline or metadata attached to the document, and where your content is going to be. So in this example, description is the content, title obviously goes into the body as well, and what we send to the LLM is the constructed document, often in Markdown. Okay, so converting records to documents. For this, I'm going to use an already executed demo, so that will help us with the time thing. So here is, we have the same intro here. We're running, setting up the Python environment. This time we're also installing LangChain, and we're using the source GitHub, as you saw earlier. We are syncing the streams this time. And I'm going to go ahead and rerun this. I ran it right before just so things would be fast. You will notice that as I run it again, it actually finishes in 1 second, and with 0 records because this is incremental. It recognized that there's no new records since the last time I ran it about 20, 30 minutes ago, and it just automatically by default gives you just the new records. I can change that if I really want to, and can say forceful refresh. So if I really want to get new data and force it to refresh everything, I can do that. But it's on by default that you'll get incremental results. So here you can see the progress printing as we're syncing that data. Cool. So isn't it nice that you don't have to program that from scratch? You don't have to reach for the REST API documentation and write your own incremental algorithms or deduping algorithms. The benefit of using any Airbyte or already built connector is that you have those things built in not only to the code, but also into the paradigm. Everything downstream understands incremental and primary key handling. All right, so here we're displaying the list of records in this, and as I mentioned, there's a lot of fields here. So there's a repository ID, node ID, repository URL, etc. So what we're going to do is we're going to call 2 documents. So this is the same place we previously wrote 2 pandas or 2 SQL. 2 documents, give it a title property, content properties, metadata properties, and true or false if you want to put the metadata into the YAML as front matter. And as we run this, you can see we're printing out a list of issues as documents. This is specifically the 10th issue. We could just grab the 12th issue if there is a 12th issue. And this is exactly what we need if we're going to send this data to an LLM to draw insights. All right, so I think at this point, I just want to show that this pipeline continues. We designed PyAirbyte to be type compatible with LangChain and Llama Index and other platforms, so you can just pass the documents that you got from PyAirbyte directly into your LLM tool of choice. All right. So I think it's important as we're talking about productionalizing use cases and building LLM data pipelines to call out things that RAG doesn't do well. I think there's so much excitement about RAG, and I've talked to many of my peers and colleagues who are doing RAG for the first time, and they've read so much about it. There's so much hype of, okay, I get these insights and the long-term memory and all this great stuff that RAG is doing for me. If you don't know what RAG is, quickly, RAG stands for Retrieval Augmented Generation, and specifically it refers to vector stores. You're getting text blurbs or document chunks or documents that are similar to your question, similar to how a search engine works. So RAG is great at getting discrete nuggets of information. If I have a 200-page document and somewhere in that document is reference to Charles or plums, I can just ask a question about plums or a question about Charles, and I'll get the relevant chunks of that document back. But if I ask a question that needs to cover all of the document, or if I ask how many mentions of fruit there are, it probably won't be able to answer that question, but it will think that it can. And the reason is because it finds the first 10 best matches, and those 10 best matches, maybe 7 of them are fruit, or 8 of them are fruit, or 10 of them are about fruit. But we don't know actually how many there are. So what I suggest as you're thinking about use cases in LLMs, you think about all 5 of these tools in your toolbox. Don't neglect text to SQL. I think that counting things is always going to be valuable, and the best way to count things is to use SQL. Also, direct filtering of a set by a filter, text to SQL is going to be your best go. I'll call it number 3, which is full document prompt ingestion. That's basically, instead of searching for the chunk, you just pass the 200 pages or whatever at the front of the prompt or in the prompt and say, here is a 200-page essay, and then after that you ask a question, but that's your entire prompt. As prompt lengths and token limits go up, those kinds of queries become more and more possible, where you might not even need to do RAG of chunks, but you can just grab the whole document, throw it in there, and ask a question. Agent tools and APIs are super important as well. I won't go into too much detail. And then, of course, there's fine-tuning. So think about all of those as you're thinking about your use cases, and don't lean all into RAG. Okay, so here in your prototype phase, we're going to go back to that demo. And of course, you've got your data, you've got your use case, run it all the way to the end. And here we're running this through the vector store. I can rerun it, but it just ran a second ago. In this case, we're just asking a question at the bottom. Show me the document-related issues along with issue on a new line. Here we're saying, we're passing this prompt to the LLM, and we're seeing that these 3 results going. This is just to say, take your pipeline all the way to the end, see what it does, and then iterate back up the pipeline wherever you find issues. Another important thing here is to find internal customers who can give you feedback all the way along. They will ask questions that you didn't think of. They'll use the tool in a different way that you didn't think of. And generally that finds issues and improves the product overall. All right. Okay, so getting towards wrap up, what are we talking about when we get to production? Let's say we started with the data exploration, we found some potential insights, we went through the prototype, we built something that seems to do exactly what we need to do. We've iterated on it a few times, and now we're ready to go to production. So if you were using kind of a throwaway code approach, let's say you went in and you wrote a bunch of code in R, or you wrote your own bespoke code in Python, or you used, I'm not gonna name check other vendors here, but like let's say you used a Canvas type design tool where you drag and drop all the things and you come up with a pipeline that way. If you haven't followed some, maybe not these exact ones, but something like these and your own internal best practices along the way, you're probably gonna find yourself in a situation that in order to actually build your thing, you have to take the blue pill and go back to the beginning and start from scratch. Where you really wanna be able to say, okay, I built on good design principles, I have 4 parts of my pipeline or 7 parts of my pipeline that can compose and deploy. Let's move on to the next adventures. Let's move on to the next things. So I managed a couple ML teams in my career, even though I'm not an ML practitioner by any regard. And we saw this over and over again. We saw these huge Jupyter notebooks being created and these pipelines being created, but there was no path to production because that ML person needed to go on to other things. They needed to hand it off to an IT person or a data engineer to maintain, and that data engineer would look at the code and say, oh my God, I can't maintain this. I have to rewrite it in a way. Some people are laughing. But yes, I've experienced this. Is anybody else here experienced that? Yeah? Okay, a couple people have. It's no bueno, because you have a product that produces some value, and what happens too many times is that never sees production, because that other person doesn't have time to recreate it, and you don't have time to create it because you're moving on to another project. Even though some value could be delivered, it doesn't. So with Airbyte, what I showed you in Python can be pushed to production, but you don't have to push it to production that way. You can spin up cloud, managed, or OSS, or you can productionalize the Python code. But you don't have to start from scratch. You designed it the right way. You didn't put weird transforms or joins in your extract and load process. You stayed away from ETL design patterns that would break at large scale. And hopefully you end up with something that promotes with very, very little change. And I'm just going to quickly, for the demo on this part, I'm just going to go into our Airbyte docs and just show you quickly. Let's say that I built this in my ML team. We iterated on Google Colab. We're having a great time. I get on the phone or get on Zoom with my data engineer, and I say, hey, like I've got this cool pipeline, but I don't want to maintain this process. Can you put it into production for me? So they spin up a Kubernetes cluster, or they use Terraform to do what I'm about to do. There's lots of options for how you deploy it. Let's bump the font. So we go to sources, and we say, for instance, GitHub. And the configuration here is exactly the same configuration we saw over there. This is important. Also, the streams that are going to emit from here are the same as the streams or the schemas that would emit from our Python code. So you don't have to change your transformations layer. Admittedly, I can't type and talk at the same time. So we have some other fields we can configure here. I can authenticate with my GitHub account. This is a nice benefit of cloud because then I don't even have to manage that personal access token. And I can do all this hopefully in a live demo without leaking anything. So yeah, so I set up that source. It's going to test it in the UI. All of these paradigms you're seeing in the UI are the same paradigms you saw in Python, just a different way of executing them. What we find is that people who love Python and who are data scientists are going to really prefer to just go crazy in Python. They don't really want to spend time in the UI. You could also do this in Terraform, as I mentioned. You can also come in here in the UI. But what we're doing is giving the tool to each team that each team wants to maintain and feels most comfortable to maintain. So now we can create a connection. Just to demo the Python, let's say the pinecone push. I'm going to skip a step and say let's say I first create the pinecone, the GitHub to Snowflake or Databricks. We can also use the same no-code approach to loading data directly to Pinecone or to my vector store. Okay, and I'm going to pause there. Cool. So recapping where we started from, simplicity beats complexity, stability is a luxury, or it's maybe not even a reality, and to go fast, do less. And yeah, we start with a tool and a set of design principles that see all the way to the finish.